A new political party, the Sustainable Energy Party, is planning to have candidates run in the next election. Researchers collected data that suggests the proportion of voters likely to vote for the party to be 23%. 1 year before the next election, random samples of 400 voters were taken in a particular electorate. Let P hat denote the sample proportion of voters who indicated they would vote for the Sustainable Energy Party at the next election. We want to state the distribution of P hat. Well, we know that this type of distribution is normal. The mean is always the parameter that we have, the 23%. The variance is calculated by doing 0.23 multiplied by 1 take away 0.23 all over 400. The 400, of course, because we had 400 voters in the sample. So we just need to calculate the variance there. And you can see I've calculated it here. I actually calculated the standard deviation because we're going to need that, and then squared it to get the variance. So the variance here is 0.0004427.5. And the standard deviation, I'm just going to make a note, is 0.02104. So we now want to calculate the probability that the proportion of voters likely to vote for the Sustainable Energy Party in a sample of 400, so same standard deviation we had here, is less than 0.2. So what we're after is the probability that P hat is less than 0.2. Make sure you make that statement because we've got 3 marks here, so we need to show the examiner what we're working out, or just put an answer down. So we have a normal CDF. With the lower, we can just make that negative infinity. The upper would be 0.2. Our standard deviation, that's why I wrote it down earlier, is 0.02104. And the mean is 0.23. And calculate, and we get 0.07697. 1 week before the election, researchers believe that the proportion of voters likely to vote for the party in that same electorate had increased. A random sample of 200 voters was taken at this time, and 55 of them indicated they would vote for the Sustainable Energy Party at the next election. Based on this sample, estimate the proportion of voters likely to vote for the Sustainable Energy Party in this electorate. So there's 55 said yes out of 200, gives us 0.275. For a 99% confidence interval, what is the margin of error of the sample proportion of voters likely to vote for the Sustainable Energy Party in this electorate based on this sample? So I'm going to use an e-activity, but I'm going to write a couple of things down as I do, just to make sure I get the marks. And the first thing we want is the Z-score for the confidence interval. Now it's a 99% confidence interval, and as it happens, that seems to be the last one I did, and therefore I can make a note of the Z99 number, which is 2.5758. And then to get the E, I'm just going to use the E activity just here. We can see the margin of error is here. So n is 200. The z gets automatically put in from my last calculation, and the proportion here was 0.275. So I've got all the right things in there. We just need to calculate E, and it is 0.0813. Now, based on this sample, calculate a 95% confidence interval for the population proportion of voters likely to vote for the Sustainable Energy Party in this electorate. And note it's 3 marks, so I'm not just going to whack that into an E activity. There's a 95% confidence interval, so while I'm here, I am going to go back to z-score for CI and put in 0.95 and solve, and that gives me 1.96. So I'm going to make a note here that my Z95 is 1.96. And then think about how we calculate these. So our proportion was 0.275 for this latest sample. Take away 1.96, and then we've got to multiply by the standard deviation. Now for this one, that's 0.275. 1 take away 0.275. All over 200, because there was 200 in this sample. And then over here, it's the same thing, but with a plus. So 0.275 plus 1.96 times that same square root. So 0.275 times 1 take away 0.275 all over 200. And now we just need to calculate that. So I have calculated that here on the calculator. So that's 0.213 at the bottom end. And all I need to do is go and change that to a plus. And it gives me 0.337 as my top end. Okay, so based on the research, did the proportion of voters likely to vote for the Sustainable Energy Party in this electorate increase in the year leading up to the election? Justify your answer. Well, the 95% confidence interval that we just calculated encompasses the original proportion of 0.23. So no evidence of increase. Now finally, we get to part G. The analysis above models the number of voters likely to vote for the Sustainable Energy Party as binomially distributed. State and discuss the validity of any assumptions for the binomial distribution in this context. So let's consider conditions for a binomial. So 2 outcomes, which we normally call success or failure. So here, vote for SEP or not. Well, I'm guessing that we could consider that success and failure. So maybe not too bad an assumption, provided there's 2 possible outcomes and not a voting on a rank system as we often do here in Australia. Independence of voters. I think that's unlikely. People do influence each other. 3, equally likely that each voter will vote for SEP. That's really unlikely. Some people will already be tied to a particular party. And so the chances of these two individuals here both having exactly the same probability of voting for the SEP is extremely unlikely. So a binomial model overall is probably not a good one here.